G'day everyone, Dicko here with another kick-ass walkthrough. This is part 4C of a multi-part series covering character rigging. And this is the final version of a spine rig that I'm going to recommend to you to build. This is the Spline IK system. And the cool thing about this is that unlike the bendy bone system, it can be used in game engines. So the great thing about this is that it can have squash and stretch. You can have all this cool cartoony shit where you can like squash it, you can rotate it, you can do all kinds of weird stuff like this. You can break it, you can do all sorts of fun cartoony stuff, and it will actually export out successfully for game engines. So if you want to have cartoony rigs, cartoony characters in your games or whatever, this is the rig setup for you. So how do we go about this? Let's start from the top. Okay, so if you recall from the previous video when I was working with the bendy bone system, I had set up a FK-IK relationship where I had both FK and IK working in tandem with one another. Now, I'm not going to change that. That's going to stay exactly the same. The setup is going to be pretty much the same with a few minor exceptions. So if you're starting out with this video, I'd suggest go and check out that video and see how I've built up the relationship. But let me give you a quick summary. So what I've got here is these deformed bones being a child of these hips here, like so, which deforms the lower, controls the lower half of the body. Then we have the FK controls, which are these ones here. So if you look at the bone setup here, like so, we have the FK controlling both the FK and IK controllers in tandem up the chain, with the difference that the midsection FK also controls the midsection IK, and then the chest region FK controls the chest region IK as well. And ultimately what we would have is a relationship where because these are now the IK controls here are independent of one another, we can pull it apart and do some cool squash and stretch stuff like so. We'll get into more detail about that in a moment, but suffice it to say, that setup is going to remain. So the only thing I've done to start off this new setup is that I've removed the bendy bones, so they've been disabled now. So if you look at the bendy bone setup here, in the edit settings here, so under bendy bones, I removed all the segments, I removed all the constraints, so they're no longer there. I don't need them anymore, so I've removed those, and I've also deleted all the helper bones that were in that previous video as well. So this is a fresh clean slate spine rig at the moment, so we don't have to worry too much about that. Okay, so what we need to do is actually start off with the spine and actually subdivide these physically. So instead of using bendy bones to subdivide, we need to subdivide the spine itself into smaller segments that can then be manipulated by a Bezier curve. So if you are wondering what that is and what the Spline IK setup looks like, check out my second part video of this series. So part 2, I talk about the different kinds of basic rigging schemes we're going to use in our videos. So check those out, and you'll understand how the Spline IK works from that setup. This takes it to another level, essentially. Okay, so to get started, what we're going to do is with these two deformed bones here, we're going to subdivide these. So in edit mode, I'm just going to go into edit mode, select those two bones, right click, subdivide. And depending on how much geometry you want to manipulate with this spine, you can either have just one subdivision or you can go with two. In this case, I will go with 2 subdivisions. So I'm going to have 1, 2, 3, 4, 5, 6, 7, 8 bones to work with in order to make my Spline IK work. Now, because these are all deformed bones, we need to actually rebind the upper torso to these bones so they can actually be manipulated by this. So in object mode, I'm just going to select my chest and just quickly do automatic weights for now. So at least then the spine will actually be manipulated appropriately. So if we go and grab these controllers now, well, not controllers, these bones, and manipulate that, you can see it's doing this thing. All right, cool. The second thing we need to do now is rename these bones. So you can see here that all the bones have been labeled in a weird order. So we need to actually rename these manually. So my quick trick is to essentially just write some gibberish in the bones for now. Just write some gibberish on that up that chain. Doesn't matter what you write. It's okay. It's all just bull crap. I'm just putting some random numbers there for now. It all makes sense in a moment. And the reason I'm doing it this way is because if I try to do the bulk rename, it would still number the bones in that same order. So all I'm going to do now is grab my original spine from the hips, which has the name Def Spine 1. Copy that. And then just paste the name into my list here. And you can see that Blender, in its infinite wisdom, will automatically name the bones with the proper number. Alright. Cool, with that out the way, we are ready to start working on the Spline IK setup itself. But you got to note one thing, that one thing is really important with this setup is that with the way that Blender exports out Spline IKs into like an FBX file, we run into what is called a cyclical error. So basically it tries to double up animation because of the way that the relationship works between the Spline IK and the rest of the rig. So what we need to do is actually separate these bones from the hierarchy as it is currently, and then have a series of mechanism bones which constrain to these bones here. And that mechanism chain will be what harbors the Spline IK. The Spline IK will drive that mechanism chain, which will in turn drive this deform chain here. Okay, so let's go ahead and duplicate this spine. We're going to duplicate these bones and then rename them as mechanism bones. Okay, so let's go ahead and do that now. Select those bones. Just the deformed bones. Don't worry about the chest. Do not worry about the hips. We don't need anything else except for that midsection torso that we have subdivided. Let's go into tab and duplicate. And I'm just going to quickly scale up those bones, like just the visual scale of these bones by holding down Alt, Control, S, just to give it some separation between those bones. So now I know that the wider bones here are our Spline IK, mechanism bones, and the thinner ones is our deformed bones. And I'm going to move that temporarily to another layer as well, so I know that those mechanism bones will live on another layer here, separate from my deformed bones. Okay, so what we need to do now is rename these guys and remove it from influencing the armature as a deformed bone system. So firstly, I'm going to select all my bones there, go down to my bone settings, bone properties tab, and just alt click deform, and that will remove those bones from interfering with any deforms in the future. So if we do any automatic weights, these will not be included in those automatic weights. All right, so let's rename these guys. So I'm going to select these guys again, and I'm going to push Control F2. I'm going to shift the data type to bones. So only bones will be renamed. I'm going to make sure it's only the selected bones that I've got here that will be renamed. And I want to find the phrase DEF and replace it with MCH underscore IK. And that will find the word DEF and replace it with the prefix MCHIK. Push OK, and you can see in the bottom there, renamed 8 of 8 bones, and you can look at the actual rename. We have our bones have been renamed up here. The only thing we need to do now is actually just renumber those bones appropriately. So 002, 003, 004. Make sure you're selecting it properly, copying it properly. So just go through, rename those guys. And make sure you're doing it in tandem with the naming conventions of your spline. So if you have the same, make sure the same numbers line up with the deform number as well, because it just makes life a little easier for you. Eight and 9. There we go. All right, so now we're ready to actually construct the spline that will end up being constrained or constraining the spline IK system here. All right, so what we're going to do is create a Bezier curve, which will then fit between these bones here. So I'm just going to quickly add a, move the 3D cursor to the base of this bone here. And then in object mode, I'm going to create a Bezier curve. Now, normally in, say, Maya, this would be an automatic thing where you just select 2 bones and it automatically creates the spline in between. But in Blender, you have to do it manually, which kind of sucks. But it works the same way. So what we need to do is, firstly, turn on in the viewport settings with regards to the spline here in the settings here. Turn on normals inside the viewport overlays in edit mode. That way you can see the direction of the normals, or the direction the spline is traveling, because we want the spline to travel from its base here upwards in that direction along with those arrows. And that's important when it comes to creating a spline IK, because that takes that into account, the actual normals of that, that spline. Okay, so firstly, I'm going to quickly snap this point to that area there on the 3D cursor, like so. And then I'm going to do the same thing with this one, but at the top of my spline here. But let's quickly turn on in front in our viewport so we can see what's going on. So let's go over to our viewport display, turn on in front, so at least then we can visualize what's going on a little bit easier. All right, let's just tab into edit mode quickly, select the top of our joints there, 3D cursor to point, grab this vertice here and do the same thing, selection to cursor. And you can see here the spline isn't exactly straight right now, but we can fix that really easily. Right click, go to spline type, switch it to poly, and now we have a perfectly straight Bezier curve. What we need to do now is a couple more things. Firstly, we need to switch that back to Bezier. That'll bring back those handles so we can actually manipulate those as part of the rig. And then finally, we need to change the handle type from automatic to aligned. And that will give us a bit more flexibility when it comes to, manipulating those things. One more thing we need to do before we can start to use this as part of our spline IK is to subdivide it once. So we want to have a single control point in the center that will basically allow us to manipulate the mid-drift of our torso here. So let's right click and push subdivide. And you can see it's added a point right there in the center there, which is perfect for us. Last thing I want to do is quickly realign these splines again. As you can see, the handles aren't even anymore. So I'm going to do the same thing I did before. Go to spline type poly, spline type Bezier, and then back to handle type aligned. And now we can see it's nicely evened across that system there. All right, let's quickly bring back parts of our rig here through the layer system. Now we can see here that my FK and IK controls for this mid-drift are sitting at this point here. But if we go to our little point here, it's not quite aligned. So what I want to do is align that point to this control here. So what I'm going to do is quickly hide away the torso for now in the geometry. Select my Bezier, go to edit mode, and then with that point selected, I'm going to turn on snapping, snap the vertex, and I'm quickly just going to snap it to the bottom of that bone there, just like that. And now it's perfectly aligned with my controllers. All right. Okay, so now that that's done, let's quickly rename that Bezier curve with the prefix CRV, spline IK, spine. And let's move that into a splines collection just for organization's sake. And now what we need to do is create that constraint. So with that in mind, let's go to pose mode, select the top joint of this chain. This is the mechanism joint chain, by the way, mechanism IK spine 009. And we're going to go to our constraints tab and add a spline IK constraint. We're going to make the curve spline IK spine Bezier curve our target. Click on that. And you can see it's gone all screwy there. So what we need to do is change the chain length from 1 to 8 because we have 8 bones in this chain. So 1, 2, 3, 4, 5, 6, 7, 8. And now, if we were to go into edit mode with our Bezier curve and try to manipulate those these points in edit mode, watch how the spine actually moves along with it, which is really, really cool. Just be careful that when you're editing this thing that you don't accidentally confirm that movement, but you can see here it's working quite well. And down the center here, you can see it's working here. And note that if I were to scale up the Bezier handles, it actually manipulates the spline as well, which is really useful for that cartoony stuff that we want to do with this rig. All right. Now, believe it or not, that's the fundamental mechanism that will drive this entire rig setup that we have here. Beyond this, it's actually just adding a little bit more finesse and complexity to make it even better. So what we need to do is firstly go into our pose mode again and bring back our deformed bones. Now, what we need to do is actually remove the parent-child relationship from the rest of the rig in this case. So we want to actually go into edit mode, and with these spline or spine bones here, the deformed bones, not the mechanism bones, the deformed bones, we want to remove the parent-child relationship that they currently have. So we want to go to Alt-P, clear parent, and now they have no relationship other than themselves inside the armature node setup. The reason we do this is so we can avoid any cyclical errors and doubling up of transforms. And this is the only way that we can effectively build something like this for export out into, say, Unreal or Maya through an FBX file. So let's go back to pose mode and bring back our spline IK mechanisms. Now what we want to do is essentially reconnect the relationship via constraints instead. So what we're going to do is select the mechanic bone first, then the corresponding deform bone, and push Shift Control C and set it to copy transforms. And we're going to do the same thing throughout the entire chain. Just repeat the process with the corresponding bone. Like so. There we go. All right, so let's check this out. So now, if we were to select our Bezier curve in edit mode and try manipulating those Beziers again, notice how the deformed bones are now moving with it. And if you see down here at the bottom there, it's actually manipulating the geometry because there is some influence on those bones. And if we brought back some of that geometry, the chest and stuff, so Alt-H, go back into edit mode, select that Bezier, you can see it's actually manipulating parts of that torso. The reason why it's not moving the chest or the top of the body at the moment is because we haven't connected up the controllers yet. But we're almost at that stage. We are practically at that stage right now, in fact. So now what we need to do is create the connection between these Bezier handles to our controllers on the IK controllers. So this is actually quite a simple affair, all things considered. Okay, so to do that, what we need to do is bring back our controllers in pose mode for now. Let's bring back our IK controllers because they're the important ones for now. We can leave the FK ones alone for now. So what we're going to do is add a hook modifier to the spline itself. And the hook modifiers will actually hook the controllers to the spline, allowing the controllers of our rig to manipulate the spline directly without us having to go into edit mode to directly edit that spline. Okay, so let's go ahead and do that now. So let's select our curve in the outliner. Let's go into edit mode. And I'm going to add 3 hook modifiers. 1, 2, 3. I'm going to set the object to the armature on all cases. So copy that to everything. And I want to hook the specific points to specific controllers. So this bottom lot, I want to hook to the hips. This midsection, I want to hook to the middle controller. And then this top selection, I want to hook to the chest. Okay? Starting from the hips, let's add the control _ hips controller as our bone influencer. And with that point selected, make sure you select the center of the point because it'll automatically select the rest of the handles there. Just click assign a few times. Assign, 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 assign. I like to do that a few times because sometimes it just doesn't listen and I like to make sure it's done. All right, let's do the middle control now, the middle point. And we are going to use control spine or control IK torso 002 in this case. And again, assign. Assign, 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 assign. And finally, the last one there. Control IK. IK 003. Assign, 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 assign. All right. Let's go out of edit mode and into pose mode and see if this works. Now check this out. If it works, boom. How cool is that? It is working like a fucking charm. How cool is that? All right. So straight away, it's working really well. And mind you, that this bone here for the chest is a child of the IK in this case. That's why it's manipulating with it. That's why it's following through at this point. Okay, so let's bring back the FK and see what's going on. So now, we understand that the FK is driving the entire upper body at this point. From this point in, it's driving the entire upper body. So the FK is actually manipulating all of the controllers at the moment really well. And then the FK for the midsection here is manipulating the IK at this point here. Cool. And then finally, the FK at this point is manipulating the chest as well. Now, there's one thing that we don't need anymore in this setup at the moment, and that is this FK controller, because we're going to run into some issues because at the moment, you may notice that, one, the IK, or the spline IK, doesn't actually have any twist going down the spline like a bendy bone system would automatically. So we actually have to manually add that using drivers. Okay. The problem is though, we have the same function on the FK here as we do on the IK here. So why would we want to have two controllers that do essentially the same thing, right? So what we can do is actually just delete this guy. So we're actually going to delete that FK control. We don't need it anymore. And we're just going to make this controller a direct child of the midsection FK instead to start off with. All right, and it's already, I think it already did that automatically. So it went down the chain. Yeah, it did. So that's now a child of that. So now if we manipulate the FK like so, it's doing its thing. The second problem we have at this point is if I move the spine up and down, it's not moving this midsection in it as well along for the ride. So it's not like sort of moving in between the hips and the chest here. So I want to fix that, just like we did with the bendy bones. And that's a pretty simple fix. Just like we did in the bendy bones, I want to create a helper bone that is a parent of that will that is apparent for the IK control. So in edit mode, I'm going to add cursor to selected at the base of that bone there. Let's make sure I got the right section. Let's go into edit mode. Let's do that again. Cursor to selected there. And I'm going to create a new bone. Again, this is a non-deforming bone. Non-deforming. And I'm going to deselect that from deforming. I'm going to rename this as MCH. Let's just call it torso parent. Torso MCH IK torso parent. Let's just do that. .001. Okay, we can scale that down in the viewport as well, a little bit like so. And we're going to make this mechanism bone a child of the FK. Control P. Keep offset. And then we're going to make the IK control a child of this new parent mechanism bone, this helper bone. Keep offset. And again, what we're going to do is add a constraint for the top of the body with a copy location. And we're going to set that to local space. And we're going to do the same thing for the hips. From the hips down, up, we're going to do a copy location, local space. But this time we're going to set it to 50% or 0.5. So now if it's dragging along, it's now coming for the ride, so to speak, at 50% the distance of our chest bone there, which is really cool. Last thing we need to do is add a damped track so we can straighten out that spine. So just like so, grab the chest bone or chest controller, grab that helper bone, and go Control-Shift-C, damp track. And now that will follow suit perfectly. Look at that. How cool is that? All right. And now let's just quickly test out this FK setup. So we got the FK working as you'd expect. Perfect. And then because the IK is at the end of this chain, it's basically FK and an IK at the same time. And we're getting that sort of manipulation perfectly as expected. All right, we're almost at the final stretch here. Last thing we need to do is bring in that twist. So we have to fix up that twist along the spine, down the chain. So the nice thing about the Spline IK system is that the pivots can work from both the hips and the chest. So what we need to do is create a relationship where we can twist from the bottom of the hips and get the twist working up toward the chest. But at the same time, if we want to twist the chest, we have the twist working down the spine toward the hips. So let's start with the twist from the hips going up to the spine. So what we need to do is select our joints here. And you'll notice that the joints on the mechanism bones here are all set to quaternions. And quaternions, when it comes to drivers, in my opinion, are a pain in the ass to work with. So what we need to do is actually convert those from quaternions to Euler. So we can do that by selecting all our bones here. You can select all of them really, just select all of them down the chain. Select our hips and also select our chest. And when you want to switch it to Euler, X, Y, Z Euler, just click on the little panel here, hold down Alt, and then select X, Y, Z Euler. For now, if you wanted to change the rotation order in any other way, it doesn't matter. You can do it however you like. This is purely for the driver to work properly. The reason why I'm using Eulers is because unlike quaternions, which has a value of 1, between 0 and 1 or whatever, with Eulers, it's based on angle. So 10 degrees, 20 degrees, 30 degrees, we need to have a more precise angle to drive the rotation. Okay, so starting with the base of our spine here. And you may be wondering, why the hell am I using drivers and not constraints to do this? Well, the reason is simple. One is with constraints, you will still get the same problem you get with bendy bones, where you would twist it 180 degrees and then it will just break. The second thing is that it gives us more refined control over how we manipulate the twist. Okay, so let's select this bone here. So MCH IK spine 002 in this case. And I'm going to right click on the Y rotation because the orientation of this spine has the Y orientation going up the chain. Right click and add a driver. And now what you need to do is, if you haven't got it open already, open up the drivers panel with a second window. And you'll see on the tab here under drivers, a new driver is here. And what I want to do is use an expression to drive the rotation with a mathematical expression. So first thing we need to do is I want to explain what the driver is doing. So firstly, this VAR is actually a statement. It's basically defining what the input is. So in this case, I want to name it as hips. So this is hips, and if you do that, just push ignore. So when it comes to writing the equation out up here in the expression, we're going to have it defined as hips plus or minus 0 or whatever. Okay, so this driver is going to be utilized inside the object of the armature, and it's going to be, this bone rotation is going to be driven by the hip bone here. So control hips 001. So now, the reason why I'm getting this error is because it can't find the expression or the label VAR, meaning variance or variant. So because they changed it from VAR to hips. So if I just change that to hips, the equation works. Update dependency. So basically what this is saying is that the rotation of my hip joint here is going to influence the rotation of the spine rotation in the Y 100%, like so. So if I rotate this guy 100% in any direction, it should rotate accordingly. The reason why it's not working now is because I need to change the type from X location to Y rotation. I'm going to keep the mode set to auto Euler, and I'm going to change the space from world space to local space. And now let's try and add that twist in the hips. And it should drive across, it should work. Make sure it's Y rotation, not Z rotation. Jesus Christ. So you can see here, it's rotating the entire chain at the moment, which is not what we want. The reason why this is happening is because the mechanism bones still have a parent-child relationship down the chain. So if whatever this guy is rotating, this one will inherit the same rotation. So what we need to do effectively is write an equation which will be essentially inheriting only a percentage of that rotation up the spine in an inverse relationship. So what we need to do is actually write in a mathematical equation to counteract the rotation. So the reason why we have to do that is, let me demonstrate. So if I were to copy this driver as it is now and paste it into all of these rotations. I'll hide that for now. If I were to paste that in now, as it is, just 1-to-1 ratio. Watch what happens. It's going to double up the rotation along the chain because it's inheriting the rotation from this guy, which then is now inheriting both the rotation from the hips and this guy, and so on and so forth down the chain. So if I rotate the hips now, look what happens. It's going to go overextend that rotation really quickly. So what we really want is this one to stay put. This rotation to actually have almost no rotation in it, but then gradually have more rotation down toward the hips. So to fix that, we need to actually add in an equation. So with that in mind, make sure you are starting from the second bone, not the first bone. So we want to inherit the rotation 100% from the hips here. But from the second bone onwards, we want to add an additional equation to our driver. So in the expression here, we want to have a multiplication of, basically we want to divide the rotation by 8 and then inverse that, rotation as well. So what we end up having, in this case, because I have 8 bones, in this case, what's 1 divided by 8? It's 1.25. So I want to have an equation like this. Hips times minus 0.125. And I'm going to put that in brackets. I'm going to update the dependencies. I'm going to save that. And I'm going to copy that driver up the chain. Until we get to the last bone. So now you can see here, all those bones have the same driver. So now if I were to try rotating these hips now, what happens? It's only inheriting the rotation a little bit. And for some reason it's screwing up there because I probably missed one of them. And I did. So I'm going to copy that driver, paste it into that driver. And you can see here, we're getting a really smooth gradation from the bottom of the hips to the top of the chest. How cool is that? Alright, but what about the top of the chest now? It's not doing shit. It's doing fuck all. It's not influencing it at all. So what we need to do is actually add an additional equation to these drivers all the way down the chain up until our second bone here, which will add any rotation we add to our top chest here, which will allow us to get that same effect down the chain in the opposite direction. And that is fairly straightforward. All we need to do is basically do the same equation, but without the minus, without adding a minus to that equation. So what we're going to do in this equation is we're going to add another input variable. We're going to call that chest in this case. So that's the variable name. And we're going to make sure it's a transform channel. Same thing, we're going to make it a part of the object armature. But in this case, the bone will be control torso IK003. Type, again, Y rotation. Space is going to be local space as always. But in this case, we're going to now add an addition. So plus brackets, chest, multiplied by 0.125. And enter. Update those dependencies. And again, we're going to copy that driver to the rest of these bones. And like magic, it will work. Copy. Paste. Paste. Make sure that updates. Yep, it's updating. Paste. Make sure you save every now and then. Sometimes it does crash if you add drivers too quickly. Paste. Paste. Alright, let's check this out. So now if I rotate the top of the chest, holy crap, it's working. There we go. So now we have squash. We have squash. We have stretch. We have twist. And you can see I can overextend it as well, unlike the bendy bones, which is really cool. And it's all working in tandem with the FK system as well, because of that relationship we have with the IK and FK. So there's no switching required. You don't need to switch between FK and IK. You can work with them at the same time, which is really, really useful. And it's working with the hips there. So we're almost done. We are almost done. The last thing we need to do is there's one tiny little niggle that we have with this setup. And this is why the driver setup is so useful in this case. Note how with the FK here, we don't get twist in the spine from the middle section like you would with a traditional FK. What we need to do is actually add a constraint to just this one bone here just this one bone in the Y that will allow us to control that twist from the center of the body up the chain, just from that point onwards. Because from the IK at the bottom, this is working fine, because this bone should be a child of the FK. So if I were to make that a child of the FK, that will rotate as planned, like so. But it would still inherit the rotation from the hips, just not absolutely, which is really cool. And of course we have the upper body, which is working as normal, but that midsection isn't really influencing much in the rotation. So what we need to do is really simple. Select the FK control, select the midsection bone that matches up with that FK control. Control Shift C, copy rotation, and we're going to disable the axis on the X and the Z. We only want to have it affect the Y, and we're going to change it from world space to local space. And finally, with that constraint, just make sure you set the mix to be set after the original. So what we want to do is allow the driver to rotate the spine control or the spine mechanism, and then this copy rotation can then be added on top of that original rotation in the setup here. So that will allow us to have full control. And now if you rotate this guy, it's working as you'd expect as an FK chain, not as a spline IK chain. So now we have FK relationship where we can bend like so. We have twist from the top of the body. We have twist from the bottom of the body. We have a pivot which can work from the hips. We can have a pivot which can work from the chest. And we have full control over the entire system. And we have infinite twist, mind you, as well. Practically infinite twist. It's a goddamn awesome system. Okay, so to cap off this whole thing, there's only one thing to be aware of, and that is the way that the spline IK is actually behaving when it is working in tandem with the rest of the rig. So notice how if I were to select the global control here and try to scale this rig, the chest, the midsection it's not scaling along with the rest of the rig. It's actually scaling in the inverse, which is not what we want. We don't want that to happen. But that's a pretty easy fix. All we got to do is go to the IK constraint, and in the chain scaling section, we need to turn off use curve radius. Turn that off, because as you can see, if you hover over it, it says average radius of the endpoints is used to tweak the X and Y scaling, or X and Z scaling of the bones on top of the X scale node or mode. That's the reason why you were getting a double up of scale there. The other thing we need to turn on is with the spline IK under the XZ scale mode or XZ scale mode, we need to change it from none to either bone original, like so, where you can scale, or you can use volume preservation. And now these two have different behaviors. So with volume preservation, you'll get like actual squash and stretch, mechanics in that system. So it'll actually squash and stretch when you pull apart parts of that spline IK. With bone original, it will maintain that volume throughout the whole thing. So if we go to bone original, it will effectively keep that scale without squashing it and squishing it. We'll keep the volume around those bones the same. I like it when it has volume preservation turned on. It's more cartoony. So you can have it either way. But that's it. That's it when it comes to the spline IK system. And now what we can do is test this out in, say, Maya or a game engine such as Unreal. So what I'm going to do is add some basic animation to this guy. And we're going to utilize whatever we can with this this cartoony rig as it is at the moment to really emphasize that it works. So firstly, let's add some keyframes. turn on auto keyframing. I'm going to manipulate this guy. I'm going to manipulate this guy. Let's add some more animation this way. Can rotate his body that way, like so. Get that going on. It's really twisting around. We can add some squish. Let's add some squash down there. Boop. Add a bit of a hold there. So really squish that down. We can stretch it up. And then let's bring it back down to 0. Alright. So now what we have is this going on. Let's have a look at the animation. 1, 2, 3, 4, 5. Alright, let's test out and see if this works in, say, Maya or Unreal Engine. Alright, so to do that, I'm going to go to object mode. I'm going to select everything here. And then what I want to do is go to File, Export, and in this case, I'm going to use a plugin called Better FBX Export. You can get this from Blender Market. It costs about 20 bucks. For game engine stuff, I think this is a better exporter than the default Blender one. It's more reliable in some cases, I reckon. So I'm going to go and choose that as an option. But you can probably do it with the standard exporter as well. So give it a go with that. So what I want to do is set it to only selected objects. Scale is 100. I want to keep the animation. I want to have only the deform bones being exported. I don't want to bring in the all the mechanic bones because they're not required for a game engine or an FBX file in this case. And I want to turn off ignore armature node here as well. So I'm going to turn that off. And I'm going to export this as Ragnar Rig 003 and push export. Let it do its thing. It will click over for a few seconds. And once it's done, let's go check and see if this was all in one piece. And there it is there. Let's open up Maya and see how it goes. Alright, so Maya has finally opened up. So let's get this Ragnar rig and just drag and drop it in there. Here it is. It looks like it's all in one piece, but let's check out the animation. Oh my goodness. Oh my damn. It's in one piece. It's working. All the deformations are working really, really well. How cool is that? And that's because of the way that we built up the armature node. So the spine deformation is independent from the rest of the body. So it allows Blender to export this effectively without doubling up on those transforms. So let's check this out in something like Unreal Engine and make sure that it's working as well. Alright, so here's Unreal Engine. Now let's bring in that FBX into the content browser. And I want to make sure that when I import it in, it's going to have the skeletal mesh. It's going to have the mesh. It's going to have import animation. I'm going to set to animated time. I'm going to set the everything else is default. Everything else is good. Import all. All right, so you can already see it's kind of looking like it's working there. So if I double click on this Ragnar rig skeleton, double click on that guy, bring in the preview. If I were to preview that animation now, it is working perfectly. Squash and stretch, twist, cartoony effects, cartoony deformation, working like a charm inside of Unreal Engine. How cool is that? Now, the setup may take a little while to get right. I don't expect you to get right in the first time because there is a bit of organization required here, a little bit of thinking, a little bit of planning. But as long as you organize your rig properly, you understand the hierarchy, and you understand the reason why the drivers are working the way they are, then I guarantee you'll get a good result out of this setup here. It is an absolutely awesome setup in my opinion, and I use this practically for every rig that I make from now on. So I definitely recommend you try it out. It's really fun once you get it working, and you can make some really fun animations alongside with that as well. Anyway, with that being said, we can now move on to the rest of the body. So that includes the arms, the legs, and the face. So in the next video, we're probably going to work through rigging the arms with a basic sort of setup. Same sort of deal. We're going to do 3 different variants of the arm. One with a very basic FK IK setup. Then another one with some basic bendy bone twist setup. And then finally, we're going to do the same thing here where we add Spline IK to the arms to get really cartoony effects as well, which will also work in a system such as Unreal. Anyway, until then, give this a go. Good luck, catches, and have fun.